here's a worked example on verifying a trig identity that comes from section 8.2. So I just thought that I would give another example on doing a trig identity that just comes from section 8.2 because I guess some of the techniques are a little different. Anyway, in this example, I am again going to work from both sides at the same time. The first thing I'm going to do is I'm going to expand the definition of sine to theta, and I'm going to use the double angle identity for that. So the 1 plus stays the same. Sine of 2 theta becomes 2 sine theta times, whoa, not cosine, not sine, cosine theta. Okay, now I'm going to leave this side alone. Let's go ahead and expand the left side of the equation. So I'll kind of make myself a little more room here. This is going to become cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. And then this gets thrown on the other side. Okay, so maybe it's becoming obvious what's going to happen here, but we can go ahead and cancel off these two values. I kind of switched up their orders, but again, multiplication is commutative, so switch those around. I can subtract both of those off and reduce them, and what's left is actually the Pythagorean identity. So this is a really good example of we kind of reduced to an identity we already know. Of course, I could do substitutions and get 1 equals 1 if I really wanted to, but this is a great example. We've reduced the Pythagorean identity, and this is thus a true statement because we know that this is a true statement. And that's really it for that example. That's a way to, reduce an identity. I guess the takeaway here is some of the problem-solving tips. If you see something that looks like a, double angle identity or a half angle formula, just try and expand it. It'll usually lead somewhere good. So that's kind of what I did here. I expanded the double angle identity. I FOILed out my values and just sort of saw what I could do from there. But anyway, that's a worked example on verifying a trig identity.